So as you are looking at exponential functions, what we want to look at is first, what are those I can statements at the top? So when we're looking at the I can statements at the beginning of this lesson, if you were going to read through those, if you would, Owen, want to read a couple of them?
I can substitute convention values for x to generate a table and graph of exponential function. I can identify any x-intercept and y-intercept, increasing frequency, inverse, maximums and minimums of the function just by looking at the graph.
So then we have our parent function, that direction. Tom, you want to read those last two for us?
I can explain that the parent function for exponentials is f of x equals b to the x, where b is a positive number. I can identify the names and definitions of the parameters a, b, and c, and f of x equals
A times b to the x plus c. So we're going to look at both of these two today. We're going to kind of look at what is our y-intercept. We don't do a lot with the x-intercept. The x-intercept a lot of times doesn't happen in some of our graphs because the line never crosses the x-intercept. But we are going to identify the parameters, like what is the a, b, and the c in our equation. So if we are looking at this, Joey, would you continue with the vocabulary?
An exponential function is a function that is repeated multiplication. The x variable is an exponent. Here is the general form of an exponential function. There are three variables that can be used in this equation.
So when you look at this, one of the things today you're going to be asked to do is tell if something is linear or exponential. Key thing, if you have x as an exponent, it's exponential, okay? Anytime you have a variable up here, it is not linear, okay? Linear is when x is to our first power. So the a is our initial value. A lot of times we think of that when x is equal to 0, so we really refer to the a. If we are thinking of that, it says the a cannot be 0. So if c equals 0, then they have the same y-intercept. So if we are looking at this, a is really going to be our y-intercept is what we are looking at in ours. So when we look at these, our a is always going to be the y-intercept. So if we're thinking of this, a is our y-intercept, okay? If we are looking at b as we read that one, Becca, do you have notes or do you need some? Do you want to grab, I think we might have the pink there. We might have some extras right on the top, kind of towards the bottom of that, close. Okay? So if we are looking at this one, Ray, you want to read for us for the b?
b is the growth or decay factor or your multiple that the b must be either between 0 and 1 or greater than 1.
So when we look at this, it's always going to be between 0 and 1. That would mean it's decaying, and our graph is going to go down to the right. If it is growth, it's going to be greater than 1. So this is usually what you are multiplying by. So when I look at the b, if something's doubling, it'd be 2. If it's tripling, it's 3. If I'm taking a half of it and it's getting smaller, that would be 1/2. That's going to be that value. It's going to be that number. If we are reading c, as I look at that, Abby.
C tells us where the horizontal
It's called the asymptote.
asymptote is. An asymptote is an imaginary line that the function approaches, gets closer and closer to, but never reaches.
Keep going.
And our class is 5 will almost always be 0.
And our class is almost always going to be 0, but this example that I give you, this line is almost, it looks like it's approaching, it gets really, really close to, but it really never would hit -1. So in this example that we have up here, that would be our value for C in this case, that it's getting really, really close to, but it's never hitting -1. Okay, so some of the vocabulary. All right, so that next part down, it asks you to give some information. If the x values are constant difference, if y values have a constant ratio, then this table represents, so if we are looking at this, when we look at a linear table, what should you be noticing about a linear function or a table? So if I give you a table and I'm asking you, what do you notice? You should have a constant difference. And when you think of that constant difference, usually it's going to be either adding or subtracting. And when we add or subtract, it's as x increases by 1 how the y changes. And when I talk about how the y changes, someone said in the last class, so you mean the slope, right? Exactly. That is that rate of change. That's our slope. So when we think about linear, remembering that when you find in a table, you're always trying to find the change in y over x. That's really what slope is. Y divided by x. Change in y divided by x. Linear equation. Y equals, anyone remember the general form? Should be what, Joe? Y equals mx plus b. You will notice that any exponent here, x is to the first, y is to the first, we don't write those in, but the exponents are all to the first power. When it's linear, your exponent is always 1. And if we are thinking about a graph, this is going to be a straight line, right? It could be an increasing slope, positive, it could be negative, right? It could be a zero slope. You can have any of those if we are looking at linear equations, right? So just that it's a straight line. When it's exponential, not a straight line, it's going to be a curved line. Our curved line is either going to go kind of like this and go really up fast, or it's going to come down, but it'll be kind of in that curved fashion that we are looking for exponential. The equation is the one we were just given. Y equals a times b to the x is the most general form. Sometimes they have the plus c, but a lot of ours will not have that plus c. So it'll generally be in this form that we are looking at. And the key thing here is that you are going to have a constant ratio. A ratio means that you had to multiply usually. So as x increases by 1, you would probably be multiplying by the same number to get the next value. What's nice about that is later you're going to be asked to look at a table or to look at an equation and try and write equations, and our equations will kind of be in this form that we are going to be looking at. Okay? So down below, right there, it says when we write equations with functions, we leave usually the a value is understood to be 1, and the c is usually a 0. So the most basic form of our equation is here. If this was plus, it's plus what? It's plus 0. There's nothing there as you are looking at that. So as we are taking a look right now, we want to look at those. They give you 3 equations. And the 3 equations were y is equal to 2 times 3 to the x plus 5. You are asked to identify the a, the b, and the c. Do that for these 3 equations, please. Y equals 4 to the x plus 1. Tell me what is a, what is b, and what is your c value for each one. They all will have a number for each part. So, most of you are almost done filling yours in. Check with the person sitting across from you or close by. Check and see if you agree. Do that now by actually talking to each other. Okay? Disconnected for me too. All right. Abby, did you check with Ryan, or are you guys not talking? You two? Yeah, go this way so that you guys are talking. Okay? Are we ready? All right, let's take a look. Owen, what do you got for A in the first one? 2. 2. In the next one, Devin? The A is 3 going down here? Oh, yeah, that's A. 1. Okay? And the next A down here, Hannah? If it helps, look back up at this general form. A times B to the x. Beck, you want to help her out? What do you think? 1. Does it make sense that there's nothing out in front of this? The 3 is to the x. So the 3 is going to be what, Mary? The 3 is our b. In the next one up from there, Tanya, what do you have b? 4. Otto, for the next b, first b? 3. If we are looking at c, Sam, what do you have? 5. Brooke, the next one? What's going to be my c value? So, again, if we look back at the top, at the page before, when we look, the a times b to the x plus c is what we're looking at. Is that general equation, okay? So, if we are looking at that one, and in our first one we said c was 5, what do we have for the next one? What should our c value be that we are adding on? Should be, does that make sense as you look at it? That it might be a 1. So in this case, we want to look at this equation. Y equals, we're having a times b to the x, and then it's plus c. So when we're trying to figure out what the a, the b, and the x are, our a in the first one was 2, our a in the second one was a 1, because this is right, they don't write in times 1, it's just understood. That is our y-intercept. Key thing to keep in mind as we look at these 3 values of a. This is specifically going to tell us our y-intercept, okay? So this is our y-intercept. This number here is telling us what we're multiplying by when we go to make our graph. So if I'm looking at that last one, Otto, what am I going to have for my c value? 0. There's nothing there, right? Plus 0. So here, this is like telling us what line it would not cross, okay? What is it going to be really close to on my x-axis? This one is going to be really close to 0, but it will never really hit 0 is what we're going to look at, okay? So at the top of the next page, you are asked to label each one as either linear or exponential. So based on what we just talked about, what kind of a table do you think it is, or the graph? The graphs might be easier to write as your exponential or linear, but do that right now. And then I'm going to have you talk with your shoulder partner about what you're putting down. And if it's easier for you to just put an E and L for linear, that works too. Okay, each one, just really quick. Look at it and trying to decide. Linear or exponential? Linear is constant addition in a table. Exponential is constant multiplication. Equations either have an x to the first and y to the first, and our graphs. So Ryan, if you were going to tell me 2 things that were linear up here, what would you tell us?
Y equals 1/4 x.
Y equals 1/4 x is definitely linear.
And the graph to the right.
And this graph is definitely linear. Okay? You're going to be asked in your homework to ask why. So it's going to say, tell if it's linear or exponential, tell why. Why, Brian, could you give us the reason for this one being linear?
Because it fits into the equation of y equals mx.
There you go. Fits y equals mx plus b, right? It matches that equation. This 1/4 is telling us that as x increases by 1, what's happening? The y increases by 1/4, right? That's what slope tells us. So you could give many other answers for your reason, but in your homework I ask you for a reason, okay? So Samantha, how about this one for linear? Why?
It's a straight line.
Because it's a straight line, okay? All right, Tanya, give me 2 that are exponential.
Y equals 3 times 1/5 to the x.
Definitely. Exponential, why?
Because it
Has
has a power.
a power in the exponent. Or 0.5 is raised to a power. Power in equation, I would take anything along that line. The 0.5 is to the x power. That is, that definition, kind of exponential. And I need one more. You don't have to give me the reason, just one more that you have is exponential.
The graph in the left.
This graph that curves, definitely exponential.
okay? And again, reason could be the graph curves, right? All right, so now we need another one, Abby. Which table do you want to go with, the first one or that second one?
The first one.
First one, what would you say?
Exponential.
Exponential, why?
Because you're multiplying the y by 3.
Multiply, I like that. We're multiplying. Each time we are taking this times 3, right? Each time we're multiplying by 3. So multiplying by 3. So as x increases by 1, our y is being multiplied by 3. So now we're looking down at the next one, and if we are looking at this one, what would you say for this table as we look at that table? Deb? Linear. Why?
Because it's constant.
It's a constant addition. As x increases by 1, right? These x's are increasing by 1. Y is increasing by 2. Constant addition. Okay, does that make sense? So part of your homework, the first 9 to 12 or something like that, ask you, is it linear or exponential? Explain why. Constant addition. Constant adding 2. Anything along that I'm going to take, okay? So just give me a reason. So next you're going to be asked to graph in your homework. They started this table at -2 to 3. Generally, I'm going to be okay if you go from -2 to 2, and my suggestion is when we do our graphs, I'm going to have you start with the positive ones first. But just so we make sure as you are doing this, we would, as you look at this, let's do your work right in front of it instead of behind it because you have a little more work. So we want to take 3 and take it to the -2 power. So from yesterday's quiz, Otto, how do I have to rewrite that? 1 over 3 to the second. So I have 1 over 3 to the second, which means y is going to be 1/9. Okay? When x is -2, y is 1/9. So I'm now looking at the next equation, substituting in for x of -1. So I have 3 to the -1. So Brooke, if I'm going to rewrite it, I'm going to have 1 over 3. So I just have 1/3, right? If we are going to continue, when I put in 0, Abby, 3 to the 0 gives us 1. When I have 3 to the first, and you don't always have to have this work, but this is how you're getting them. Some are going to be a little more complicated. This one should be 3, right? And then Hannah, if I'm going to continue, I should have 9 and 27. So it says when you look at the pattern, what pattern do you notice in our y column? So if we were looking at this, it looks like what is happening in this y column, if you were going to say what, Hannah? We are definitely multiplying by 3. So when we are taking a look at that, when we look at our y column, it is repeated multiplication or times 3 each time as you go down that column. Now, if we would have had our column go from 2 to -2, you still have to think of going, then you'd maybe go up your table, and that's what I'll talk about when we're doing our homework. It says the key feature of exponential functions is always going to be repeated multiplication. And what you can always do to figure out what the multiplying factor is take like your newest value, like take 9 and divide it by 3. 9 divided by 3 is 3. 3 divided by, and always take it by the previous one, and that will give you what your multiplying factor is, okay? Because you're going to need that. It's called our growth factor that we're going to talk about, okay? All right. So now we're looking at these equations and we're trying to figure out which equation matches the graph. Now, we can kind of see a couple of key points. This point, if you notice this is 4, where would you say this point is? 0 what? This is 2, right? This is 4. So this is probably 0, 1, right? Where is this point right here? Joey, what would you say?
1, 2.
Careful. Look at the scale. So if this is 4, this is probably a 2, and then up 4. Okay? So let's just kind of make sure we're identifying where those points are on each one. Because when you're trying to do this, figuring out which is which, right? This is -2, -4. You should be able to plug in the x value, and it should give you the y value in the equation. That's how you can kind of check to make sure, right? So this is
another one where you're at 0, -1. And here we're at 2, -4. This one, if we are looking at, is at 0, 1, and -2, +4. Okay? So as we look at these 4 different graphs and their equation, I want to check. So if I am checking, I want to take a look and plug in x is 2. Which one will give me, if x is 2, will give me 4? A, B, C, or D? If I plug in x is 2, I need to get y is 4. If I do it in this one, will it work? No. If I plug in a 2, right? If I plug in 2 here for x, this is going to be 1/2 squared. It's going to be 1/4. Which one does give me 2 1/4? And +2 gives me a +1/4. Okay, so let's just wait if you're not sure. Which one's going to work for the first one? Should it be C? Does that make sense that it could be C? How do we check it? Oh, look, my y-intercept is 1. This has a y-intercept of 1, right? If we plug in y equals, we're supposed to have a 4 here, right? That's our y is 4, equals 1 times 2 to the second, is that true? 2 to the second is 4, times 1 is 4. That matches here. This was my answer, okay? I look at this next one. It has a y-intercept of -1, which means it either has to be B or it has to be D, right? So now I got to figure out which one. I know they both have a y-intercept of -1. If I plug in -2, which one is going to give me -4? So if I plug in -2, right? -2 means to take the what? If I have it as an exponent, it means take reciprocal, right? So if I'm looking at this and I have -1 and I have 1/2 to the -2, that really means -1 times 2 to the second. That means when I plug in -2, I should get -4. -2, -4. So if I am looking at this one should be B as I'm looking at. Does it make sense why we get B for an answer? Okay. So now you have to look between these two. What would be if you're left? So we've already got B and C. And the multiple choice, what would be the deciding factor for which one is which? What could you look at? The y-intercept. So A has to go with which one? The third or fourth graph? Fourth, right? Y-intercept is 1. Y-intercept is 1. So this one has to be A, which means this one has to be D. How could you then check to make sure that you did it right? You take, so if I'm saying this is D, that means y is -4. -4 should be equal to, in that equation, -1 times 2 to the second. That's a true statement, right? How do I make sure that A was right? I plug in, when -2 is 4, I had 4, that's the y value, equal 1/2, 1 times 1/2 to the -2. Oh, well, I remember that means reciprocal, and this is 2 to the second, and that does give me 4, okay? So it's really, you can always plug those numbers in, that x and y, and check them. So it says, how are the y-intercepts represented in these equations? The y-intercept was always the what value? The A value. And in our case, it was 1 or -1, okay? And if you look at what we put those points, and some of you have these written in your notes and some of you don't, but these were what we were looking at, right? This was a 0, 1. This was a 0, -1. Here was 0, -1. Here was 0, 1. That was my y-intercept of the 1 or that -1. It says, what does the base or exponent represent in our equation? It's going to tell us, if we are looking at it, that B value tells us what we are multiplying by.
So it's the repeated multiplication. And when we're thinking of that repeated multiplication, in our case, we were either doubling it, taking it by 2, or it was getting smaller, and we were taking it times a half. So when you look at B, as you go to the right, it gets smaller and smaller and smaller, as does D. It starts really large and it gets smaller and smaller. That's because what were we multiplying by in both, if we look at both A and if we are looking at both A and B, these two, as you go to the right, they're getting smaller and smaller values. And not necessarily smaller on this side, but these two are almost like they're mirror images of each other reflected over that line, okay? All right, so this is what your homework you have. I think there's 8 in your homework where you're asked to graph. So how do you graph it? I need a table of values. So you're going to start off with giving me an X and a Y table. The X and Y table, you can start with the negatives. My hint would be I would always start with 2, 1, 0, -1, and -2. You need to have 5 values every time you make your graph. And you can do this right on the graph paper, right by your equation. So you can make this table like this and put X, Y with the problem number, and then right behind the Y put the equation, 0.5 times, in this case, 3 to the X. So if you need to show your work, you might want to show your work back here, and this is putting in 0.5 times 3 to the second power, which really means I'm going to take a half times 9. Half of 9 is 4.5. This is an ordered pair, 2, 4.5. So add 2. I want to see your scales usually going up by 1s on your graphs. Don't, possibly by 2s. I do not want graphs going up by 4s, okay? So when you do this one, 2, 4.5 should be here. We plug in 1, we're going to have 0.5 times 3 to the first. That means half of 3, which is 1.5, right? So at 1, we should be at 1.5. When we plug in 0, what's our y-intercept here? 0.5 times 3 to the 0. That is simply 0.5, right? Which we could have done this right away, right? By looking up here. That's our y-intercept. So at 0, I need a point at 0.5. Please figure out the last 2. And my hint is, as you do this one, instead of using 0.5, use a fraction, 1/2, times 3 to the -1, which really is going to mean 1/2 times 1/3. Write this down, Joey, will you, for us?
Yes, sir.
Yep, for the work, so you have this, so when you're looking back. Good. So again, 1/2 times 3 to the -2, and you're going to give me those fractional answers. Good. So Samantha, if I multiply a half times a third, I'm going to end up with 1. No, just multiply.
Oh,
I don't want the decimal. So I take the numerator, right, times the numerator, denominator times the denominator, 1, 6, yes. And Abby, if I'm doing 1/2 times 1/9, 1/18. Now, I am okay in your homework if you get decimals, but you really should make sure you understand that that negative exponent means reciprocal. Because definitely in your homework, you want to use your calculator. When they're taking 0.4 to the -2 power, definitely put it in your calculator and see the value. So that if we were looking at these last two, we had at -1, we had 1/6, and then we have 1/18, and it's getting closer and closer to 0, but this one is never going to reach 0. Okay? So as my values go out, it's going to keep getting closer and closer and closer, and when you get into calculus, you get to study limits and approaching that line of that one line that we read about, our asymptote that you're looking at. So it's closer and closer to that. So what are the values of A and B in our equation? Please write those down right now, and then we're going to talk about what they meant in our graph. Okay? So look back at your A and B. Tell me what is A, tell me what is B. Check with the person by you or next to you and see if you agree what your A and B values were. Some of you haven't talked to anyone next to you. Try it. It's a good thing. All right, are we in agreement? Ryan, what did you guys decide? A is what?
0.5.
A is 0.5. Brooke, how about B? 3. So the question is, how do these affect the graph? The A tells us what?
Ryan.
Or not Ryan, Joey.
A tells us that you're multiplying b to the x by 0.5.
No. A tells us what? What was the key word? Go back, look at your page before in your notes. What is the A value? Brooke, it's our y-intercept. So this is when x is 0. This is telling us that we have to have this 0.5. So when we look at that, and I look at A is 0.5, that is this value right here, 0.5. That A always tells me the y-intercept, okay? But then, Joey, what does the B tell us?
B tells us
That's what you said before you got these two confused. The B is telling us that what?
that you multiply these y-intercepts by itself.
So, not by itself, but as x increases by 1, each time my x goes up by 1, right? So I go from -2 to -1 to 0 to 1 to 2. These values of y are 3 times more each time, right? If I take 1/6 times 3, I'm going to get 0.5. If I take 0.5 times 3, I'm going to get 1.5. If I take 1.5 times 3, I'm going to get 4.5. So this is what I'm multiplying by. So the B tells us that we are multiplying by 3. So as x increases by 1, x increases, right, by 1, y is going to increase by a multiple of 3. The y is multiplied by 3. Okay? So you're going to be asked to do some graphs. You don't always have to show this work, but if you're struggling getting the y values and you can't figure out what they are, you are simply plugging into that equation, okay? Most of them that you're going to do in your homework are going to be curves, okay? So I want you to take a look. You are going to be doing number 9 to 13. This is where you're just asked to tell me linear or exponential, and then it says explain, okay? So just like we did in that first part of your homework. Tell me linear, exponential, explain. When you get down to number 14 to 17, by all means, you could use your calculator, but please write down the problem. F of x equals 6 to the x. Then right behind that, you're going to tell me, oh, f of 2 equals. And f of 2 would be equal to 6 to the second power, and then you'll put your answer, okay? You're going to do the same thing with each of these. My guess is that hopefully before you leave here, you are at least through number 18. And I want you to read number 18 right now, because this has kind of confused some people. So, Devin, you want to read it for us?
Investment of $5,000 doubles in value every decade. The function at x equals 5,000 times. Where x is in the order of decades small but modeled by the value of investment. Which is investment.
So, Hannah, when we look at it, it tells us it's doubling. That in the equation is the 2. And when I look at the 5,000, that's how much I started with. X stands for, what did they say, Hannah? X stands for a what? Underline. X is the number of what? What does it say X is? X is the number of decades. Decade is how many years? 10 years, okay? So when you read this, if I'm going to put it in my calculator, should I take 5,000 times 2 to the 30th power for 30 years? X stands for decades, right? So when I go to solve this, and I'm going to do problem 18, I need to plug in, I'm going to write down this equation, and I'm actually not finding f to the 30. I am really finding, in this problem, f to the 3, because 30 years is 3 decades, right? 30 years is 3 decades. So you just got to be careful. So some people in both 18 and 19 are using this 45 years or the 30 for the x. This one tells us X is the number of 15-year periods, right? So how many 15-year periods are in 45? That's what you have to look at, okay? When you go to make your graphs, I'm going to give you 2 pieces of graph paper because my hint is, as you make these, you probably want to have your graph just on like one graph here and one. We're going to do each of these, okay? So we're going to give you 2 pieces of graph paper. When I go to look at, say, number, say I'm going to do number 23. When I do number 23 on my paper, and I can write this right on the graph paper, I can put an X, I can put Y equals negative 1/3 to the X power. So it's going to be just like we did in our notes. I'm going to go from 2, 1, 0, negative 1, and negative 2. Okay? I am going to plug in and put in 1/3 to the second power, right? I'm not squaring the negative, right? I'm just squaring the 1/3. So all my values should still come out negative when I do that. The negative exponents are still going to come out. Then what I am going to do is I'm going to make a graph. Now when I make this graph, this is my Y. If I was plugging in the values, I'm going to have a negative 1/9 here. I'm going to have a negative 1/3. I'm going to have a negative 1, right? That's my y-intercept. Do you agree it should be a negative 1? When I plug in negative 1, I'm going to take negative, and it's 1/3 to the negative 1. That means I have to take the reciprocal of this. What's the reciprocal of 1/3? Negative 3, right? Negative 9. So when I go to do this graph, what I was talking about on the graph paper, you have this divided into your 4 sections. You're going to always put the y-axis kind of in the middle of those 4 sections. But some of yours, because look at this goes from negative 1/9 to negative 9. I'm going to put the x-axis way at the top for this one, right? So I can do all the values from 0 down to negative 9. But other times, I notice that my values are going to go from like 0 up to 16. Then I'm going to put my x-axis here. So that when I draw this, right, at 2, I'm at negative 1/9. That's right here. At 1, I'm at negative 1/3. At 0, I'm at negative 1. And then I'm going to have negative 3. At negative 1, I'm down at negative 3, right? So this is what my graph is going to look like for that one. Yeah.
Wouldn't it be negative 9 for, wouldn't it be negative 9 for negative 2?
I have that.
Or, wouldn't it be positive?
The negative isn't being squared. The negative was not in the parenthesis. So this means a negative 1 times 1/3 to the second. To the negative 2. And that negative 2 is going to make us take the reciprocal of that. So it really means negative 1 times 3 to the second. Okay? Does that make sense how you're going to sum it? So make your table first. Because if you have your y values all negative, you're going to put that x-axis towards the top. If you have all your y values being positive, put the x-axis towards the bottom so you can see all of those, okay? Because they're all going to be curved lines, okay? So, you got your graph paper, get started. I am going to hand back your quiz to those of you that took it and those of you that did not. We need to try and get you